Hello and welcome to IRS Rail webinars. This is part 2 of the two-part webinar series on how can the rail infra sector implement FRMCS with maximum efficiency, produced by the International Railway Summit in association with Frequentis. I'm Joel Somura, the Managing Director of IRIS Events, and it's my pleasure to welcome you all to this session. So at the last count, we had over 260 people from 47 countries registered for today. Welcome to those of you attending our webinar program for the first time, and welcome back if you've joined us before. In part 1, we talked about the transition to FRMCS. We discussed how we could make the transition seamless and cost-effective. Today, we are going to explore the post-implementation stage, specifically ensuring efficient FRMCS connectivity in rural areas, where the 5G connectivity might be weaker than in urban areas. This is an important topic for railways, which are becoming more and more digitalized and connected. Only yesterday, you may have heard that Elon Musk announced at the Mobile World Congress a $30 billion investment in his satellite project, Starlink, which aims to fill the geographical gap between not covered by fiber and 5G with their 1500 satellites. One of the audience polls today will ask you about whether satellite communications should be in the mix for rural coverage, so you have a say on this topic later on. I'm delighted to have the support of leading opinion makers and innovators as speakers with us today. In particular, we are fortunate to have the support of Frequentis, which allows us to provide this important debate on Anyone to Watch for free. Frequentis is a leading global expert in safety critical communications. Many of the world's key rail infrastructure managers rely on Frequentis' control center communication systems to provide day-to-day operations communications, as well as incident and crisis management. So I look forward to learning about Frequentis' solutions on FRMCS connectivity in rural areas from their Head of Public Transport Solutions, Markus Mislivits. I'm equally grateful to Dan Mandok from UIC, Markku Voutilainen from the Finnish Transport Infrastructure Agency, Eric Giraud de Juzeau from SNCF Réseau, and Carlos Rincon Abel from ADIF for sharing their expertise with us today. This is an interactive session. The audience members are invited to participate proactively in the discussion. So you'll be able to chat. There's a chat screen where you can type your messages to fellow attendees and speakers. You can ask questions. If you go to the Q&A section of your screen, you can send questions, and those questions will be picked. Some of those questions will be picked up by the moderator, Robert, and it will be asked during the panel discussion segment later on. And there will be 6 polls today, so the audience members will have a say on a number of issues, so do look out for that, and we'll be asking you those questions later on as we progress. And there is also a handout section where the presentations from today will be listed, where you can download these presentations for you to read afterwards or share with colleagues. And finally, there will be an evaluation at the end of the webinar. So do please complete this so we can learn your feedback and improve webinars for the future. We're tweeting live during this webinar. You can follow us at @Rail Summit, and please use the hashtag IRSRailWebinars. If you enjoy the session, do continue the debate on Twitter and LinkedIn. Now it's my pleasure to introduce you once again to our guide for this webinar series, Robert Sarfati. Robert has a wealth of experience and expertise in railway telecommunications, especially in GSM-R, and he's one of the creators behind FRMCS. Robert is Director Consultant at SYSTRA, the International Railway Consultancy. He's also the chairman of the influential European Railway Radio Implementation Group within UIC, the International Union of Railways. Robert also chairs the Technical Committee Rail Telecommunications at ITSI, the telecom standard organization. So Robert's expertise makes him a perfect moderator for today's debate on how can we ensure efficient FRMCS connectivity in rural areas. Robert, over to you.
Thank you, Gilles, for this introduction. And I'm quite pleased and I would like to thank you for participating to this second webinar. The first one was very popular and I'm happy with that. Now, just a few words, very quick and very short. After the success of worldwide success of GSM-R, now we launched the UIC launched the FRMCS, Future Rail Mobile Communication System, which is the next generation 5G based system, which will be in place in railways in, let's say, by the end of the decade, with the pilots and everything done during this time. And we think that and I hope that we all are sure that it will be as successful as GSM-R has been in the past. For that, as indicated by Gilles, we have key speakers today as well. And to start with that, I would like that we have the poll launched now and you will be able to answer to the first poll questions.
Thank you, Robert. Yes, so the audience members can vote the first poll questions. So on the secondary line, with the coverage ensured by the MNOs, what is the expected quality of service? Is it the same as on a line covered with FRMCS, or is it lower than on a line covered with FRMCS but sufficient for this line? Or is it too low for the requirements of the modern train? So if the audience members can select the options that you think would makes more sense, you have maybe 20 seconds to vote. And Robert, over to you if you want to introduce the speaker.
Yeah, thank you, Gilles, for that. I would like to just introduce Dan Mandok. Dan Mandok has worked for Romanian Railways, his highest position being head of the Telecom Digital Management Center, the head of the network, as a matter of fact, between 2006 and 2014. And then he worked for the UIC since that time, 14, where he was a coordination team, delivery of the 2 ARAIN editions. He coordinated the GSM-R interference activities, the TCS over GPRS project, and launched the FRMCS activity as UIC Eric Chairman. Between 2014 and 2019, Dan worked for Network Rail as professional head telecom. Starting December 2019, he returned to UIC as head of FRMCS and cybersecurity solution project manager. Then he graduated from the Transylvania University from Brașov in Romania. Dan, the floor is yours.
Thank you, Robert. Next time I should review my CV, because everything that was done in UIC was done together with Robert, who is a great person in this small world of railway telecom. So everything that is there, Robert was also there, and we worked together since many years. I think with good results, I hope. So at least this is an overview.
Before Dan, before you continue, let us share the poll results with the audience. So thank you, audience members, for responding. You can see the results of the polls in the poll section of your screen. If you go to polls and then closed, I think there's a clear winner here. Almost half of you have responded.
Can I bet before you say the figure, or just after, Jules?
No, tell us.
I think it's the B.
That's right. That's
Yes.
that's the answer. That's the favorite answer. But there's still quite a number of people who've optimistic people who answered A as well. Robert, Dan, would you like to maybe comment on that before Dan starts?
Robert first.
Yeah, with pleasure. Yeah, sure. The getting that I see at least that 49% got the right answer from my point of view as in telecom since say 40 years maybe, and especially with railways. The same as the line covered with FRMCS. There is a big implication with that. It implies that probably you should know, and you are provided familiar with the quality of service which is required for GSM-R today, which will be equivalent for FRMCS, owing the fact that 99.995% of the time the link is to be ensured with the quality of service which is required, and probably the question was wide enough but interesting to see that still some people think that this is possible. Dan, you can comment as well on that and see your opinion.
I think that more different lines could have in the future a different quality of service. When you have a regional line with a reduced traffic, you can call it regional, you can call it secondary line. I would say 6 trains per day. Then, and especially if it's a single line, then you can have operational rules. And at the end of the day, the government has to split the money between education, army, terrorism, all those things, and transport. And in transport, it's roads, airports, naval, and railways. So railways have to prove they worth this money. So depending on the traffic and depending on the needs, you can have a reduced quality of service, but with operational rules, you could have a safe traffic. It depends on so many things. Okay, so I will start my presentation. I have to tell you, I would like to tell you in 10 minutes actually why we're doing FRMCS. And I'd like to focus on the UIC FRMCS project position related to the MNOs, the mobile network operators. Basically, I suppose everybody, I'll go very fast on this one because you should be aware about it. Everybody probably in the audience know that today in Europe, most all the train and almost all the lines are covered with GSM-R. I think today 70% of European railway lines are covered with GSM-R, around that. GSM-R is a system that is proven to work. It delivers emergency call, which for me is one of the biggest safety improvements since the train was done. And most importantly, also it supports the European train control system, which is a warranty of interoperability. GSM-R is fully interoperable. Basically, when you cross the country, you don't have to change anything. There is no problem, and it is proven to function. However, we are introducing FRMCS for 2 reasons. First of all, GSM-R is a 2G system and is becoming rapidly obsolete. And therefore, we need to change it with a different system. And this will be a challenge because we have to deliver this capability, emergency call, which have to work 100%, a good quality of service. And then we, as railways, we have a different life cycle. We want a 15-year system. We have to ensure the cross-border interoperability and the European migration will be very different. Not every country will migrate in the same time. But all is not bad. The FRMCS is also a 5G system and therefore will support railway digitalization by improved connections and improved transmissions of data in the 2 senses. We have a plan since we started this activity since 2010, and they are organized in UIC as a project since 2014. And we have now a plan in 3 steps to deliver a system. Our goal is to deliver in the second half of 2025 an FRMCS first edition available for early implementers to procure, which will be a 5G system, 3GPP Release 17, or if you want 5G third edition system, based on the mission critical framework. And this is what we're working on very strong now. The first step is deliver specification and the migration scenario. The second step is to do prototyping, and we are doing this now to get today with a project called 5G Rail, and deliver a second step, a second version of specification, and start all the other things needed for migration, because it is extremely complex. Maybe one day I'll come and I'll tell you in 20 minutes just a bit about this complexity. And then the third step will be to do European trials. Well, I want to say something very important, that the migration to FRMCS is not a national problem, it's an European problem, because GSM-R is a European system. And therefore, if you want to have interoperability and you want to have a system which is cost effective and it works, it's interoperable and safe, you need to do it at European level. And therefore, this system has to fit with all the European members' needs, which, trust me, they are very diverse. I prepared a slide which sometimes I'm criticized about being a bit rough on this one, but it's just reality. So why are we so different? I discussed this with many people from many environments. Basically, the problem, we were told, what's the difference between trains and cars? What's the difference between trains and boats? Well, the difference is a bit simple. The train is a very heavy thing, 400 tons or more, running 180 kilometers per hour, and sometimes even 20 kilometers per hour, and braking in more than 1 kilometer. It cannot steer right, it cannot steer left, it can advance or brake. That's it. Or go back, but it's not the case for a train. And therefore, it needs to know what's happening in front of it, with two blocks, which is around 3.2 or 3.5 kilometers. And to do all this, it needs a very strong quality of service, and it needs special capabilities to be able to do, especially the voice communication, which have to function, I would say, 100%. And these are systems like group calls, function numbering, location dependent addressing, all these features that you cannot find in your phone today. To reach this quality of service in Europe, we have today allocated dedicated frequencies, and you can see down the decision and which are these frequencies. And just to explain you what is happening when it doesn't work, if in ETCS the telecom system fails, then the train will stop. The train will first slow down, and after a certain timer, depending on the national rules, is going to stop. It means that all the train behind will stop, and they will take hours to restore the traffic. Now, what does it mean if an emergency call doesn't work? It means that in one of 600 cases or 1,000 cases, a train packed with people will go with full speed towards a disaster place where another train full with people has derailed. And this is a true case. I'm not going to say where and when. This is a true case where emergency call worked. It's as simple as that. You do the mathematics for it. I also put on the right-hand side other issues that you have to consider, like the frequency aspects. How do you put the antennas on the roof? Do you do it interoperable? All these kind of things. Then the problem of asset maintenance, because exceeding in the railway space, it's a very complicated thing, which needs a lot of process, which is a normal thing. And then finally, legal responsibility of the infrastructure manager. We have been asked by DG Connect to deliver a railway 5G policy, which is the SDA, Strategic Deployment Agenda, which is about 5G and spectrum for rail. This is a document that you can find on the DG Connect website and on a CR and EIM website, because CR and EIM were the one that were asked to do it as legal, I would say, stakeholders. We have supported as UIC, ERA was there, and suppliers and a number of railways. Basically, here you have a quote on what is being said in this document related to MNOs, which is that for the first bullet point, it says clear that when you do critical communication, we are using the ECC allocated frequencies, and we could do also limited a number of train performance applications. If we want to do passenger connectivity via the MNOs, the passenger connectivity will be done by MNOs, which is the so-called gigabit train. Depending on national policy, of course, public services might be used for regional lines, performance applications, or a backup. But this is a national item, which is subject to national regulation, liability, and the national legal constraints. In other words, you have to have an agreement with your railway authority. And last but not least, we should not disconsider in any way the 5G active network sharing, the so-called slicing, but it is a challenging functionality that has to be proven. And critical aspects like interoperability, quality of service, sub-level agreement, regulation, and legal issues, and liability requirements must be very carefully scrutinized. This is what you can find written in this policy. What are we doing as the FRMCS project for it? It would be wrong not to discuss this. Today, we focus on delivering the version 1, which is dedicated to the TSI 2022 and to the 5G rail project. But we are determined to discuss the MNO, about the MNOs, and determined to understand how can we get there in a structured way. And we have to start from the needs. Which type of applications? What type of network architecture? Which technology? Which radio access technology? Is 5G NR? Is FRMCS dedicated band? Is satellite bands? Is non-GPB other satellite access? What are the SLAs for maintenance and QoS expectations? And is it a favorable business case? When we have this answer, and it should be there before in Q4 this year, we will determine the right architecture for the FRMCS onboard network side. We will need to sort out technical constraints, especially for radio conditions, with a special focus on the onboard, clarify the administrative and legal constraints, and discuss the optional versus mandatory character TSI with EC and ERA. For me, for us as UIC, this is something that basically it's a decision from EC, but we will support the discussion and we will support once the decision is taken to put it into place. To make it clear, what does it mean mandatory? It means that this facility or this frequency has to be in all radio onboard gateway or TOBA boxes, as we call them, FRMCS TOBA boxes in Europe. This is what it means mandatory. So we have to be very careful when we put something mandatory. And last but not least, of course, we will incorporate the results in a version 2 specification. So we are fully supported to this, but as I said, in a structured way, and we'll start this work in the autumn. Thank you for your attention.
Thank you, Dan, for this very interesting introducing the subject of the FRMCS for rural areas and how the FRMCS could fit the expectations which of the railways, which are professional business rather than just a public aspect. Now, I would like to say that coming from the overall view of the FRMCS, I would like that there is an essential part of the network which allow the efficient communication between the train and the track is the control room, which is a sort of supervision of what's which is how to control the overall system in rail and offer the service which is expected. For that, I would like to first see Marcus Mistivec from Frequentis will provide us with a presentation on this essential part of the network.
So
after that, I would
Robert, let's ask the audience the second poll question proposed by Marcus. So yes. So the question is, which radio access technologies are most feasible for rural areas? And you can answer multiple times. And there are 6 options proposed here. TETRA, GSM-R, 4G, 5G, satellite, or Wi-Fi. Which of the following radio access technologies are most feasible for rural areas? So if the audience members can respond to this question while Robert introduces Marcus.
With pleasure. Marcus has a long experience in railway telecommunications. And as a matter of fact, I met him when he was starting as a software developer for GSM-R mobile terminals. And then he went to the technical leadership in fixed line operational communication project. He represents Frequentis within also at CTCRT, and which is the standardization body for telecom, and in particular for rail telecom. And he represents Frequentis also in the committee of UNIFE, which is a professional committee of for telecommunication for rail. Within the company, Marcus owns the technical strategy of the operational communication solutions within the business and unit of public transport. He is heavily engaged in cross-industry transfer of knowledge and technology, as Frequentis provide communication information systems for not only for public transport, public safety, but also air traffic control domains. Marcus, the floor is yours.
Thank you, Robert. I still remember the pleasure sitting in a shelter doing the first GSM-R test in Charles de Gaulle Airport near the TGV line during the Moran project. And so today we are here talking about 5G satellite and public networks, an amazing success story.
Great. Marcus, before you start, let's have a look at what the audience have voted. So we're closing the vote now. If you haven't voted, maybe you have 3 seconds. Oh yeah, it's closed now. Thank you. So if you could, audience members, if you could go to the poll section once again, and the closed, you will see the results there. So there's, I think it's sort of nicely split. The satellite is the biggest option, followed by interestingly 4G. That's quite interesting. Robert and Marcus, would you like to comment on that?
Robert, you want to start?
With the satellite, I can see that 4G is a second, and 5G is 9%, and then go to 11%, 13%.
I think there may be a slight connection issue there, Robert. We're hearing a little bit distorted sound. Maybe Marcus, you could comment on the result.
Honestly, that sounds now a little bit selfish, but I was expecting that the audience is after not the usage of the one and only radio access technology for rural lines, but there's a split between the technologies, and there's a perfect fit because, as Robert mentioned, all these technologies have to be used in a control room. So I would like to show you how we intend to do this in the context of FRMCS.
At least I just a small comment from my side. Could you imagine capability with so many technologies? That's all. I have just a question on that. Thank you, Mark.
So thank you. Well, let's start with a short flashback to ancient times when the exchange of information over far distances in rural areas kicked off using fire and smoke. That's a concept we know from Western films and Lord of the Rings, and then later on introducing semaphores, the far distance communication experienced a boost in terms of range, and by the invention of the telescope in the 7th century, that enabled the usage of optical telegraphs to extend the range further in the rural areas. And what's very interesting, today we are back to optics in our communication. So to say, we are back to video, though we hardly care whether we have 5G, 4G, satellite, Wi-Fi, or a coax cable to enable us to communicate verbally and visually with our remote party. Like the control room user must be aware of the situation of a train at any time in urban as well as in rural areas. And this situational awareness at any location and independent from the available communication technology is significant for our domain, which is railway in general, and of course control rooms when we look at Frequentis. Still, we must not forget what is our core business. It's to keep the trains moving, not to line them up, as Dan mentioned, in case of an incident, to provide a good service for passengers as well as for freight. And for that, we need communication networks of various technologies, as we have just seen. But in any case, thinking about QoS and other KPIs, as Dan mentioned as well, these communication networks must be safe, they must be secure, they must be highly available, because we in the control room, we want to use them uninterrupted in a very flexible and independent way between the control room and the rural areas. So talking about trains in rural areas, our topic today, we shall be aware that there is not that typical train in that typical rural area. But there are various types of trains, as you know for sure. Just think about freight trains versus the ones for passenger services. Freight trains are rather than one high-speed ones, if I may say so, whereas for passenger services, we have high-speed trains as well as commuter trains. And likewise, there are various types of tracks. So we have main lines, but we have, of course, also branch lines and secondary lines. And the trains run over them either frequently with a short turn order, or rather infrequently, maybe just 4 services per day on a secondary line. And still, the train services, so that the rail tracks, they become more and more important. Also the control rooms, of course. We just think about the Green Deal of the Commission, the ambition to push freight from the road to the rail. The massive intended investment and funding programs on various levels. And to operate and to control all these trains and all these tracks, we need connectivity between the train and the control room. As of today, we've already heard that, we can only use, if I may say so, rather limited technology to establish a connection between a train and the control room. This is mainly GSM-R, a so-called 2G or second generation technology. But still, for rural areas, be aware this GSM-R offers the advantage that due to its kind of the radio access, it's a combination of FDD and TDD, and the used frequency range, the 900 megahertz band, you can build up a rather big radio sets, covering, of course, then a rather long section of a rural track. But of course, here you have only one bearer for all, be it voice train control or any other application. When we introduce FRMCS, the Future Railway Mobile Communication System, then we gain additional radio access technologies. They become available. FRMCS as such, of course, focuses on 5G, on the 5th generation technology. But Wi-Fi or even satellite, as reflected in the poll, are currently discussed and may be considered in the system definition and in standardization as well. Satellite, of course, might be a hot candidate for rural areas, if we put thunders aside for a moment, because you need no trackside infrastructure. And this is a concept we know, at least I know, for example, from Australia. Looking at the 5G itself, we have there various frequency bands. We have not only the one reserved for USC in the 900 megahertz range, you can also use other ones. And we can even think about usage of slices of public networks, or at least shared networks. So why would we not build a country-wide mission-critical communication network infrastructure and use it for public safety and for railway in a very flexible way? That's a concept we know already from our Finnish friends today, and the Finns, as well as other countries, tend to apply this in the future with new broadband networks again. However, we need to be careful that not each radio access technology is suitable for each use case, for each line, for each train frequency. And of course, during the whole transition, as pointed out, we must secure the investments, so to use the most suitable radio access technology in a very flexible way, in especially to guarantee the communication between the control room and the train at any point in time. Well, this is a functional view of the FRMCS, and I will not explain this because we did this already in the first part of the webinar. I would just like to do a very short recap concerning this very flexibility and usage of multiple radio access technologies for the various areas. You see here the split in the various stratums. So we have the transport stratum and with the core elements, then the service stratum with the session media handling and the basic services and the applications on top, which are here on right in this diagram. On the very left, we have then the user equipment and the clients who use the transport stratum to access the applications. These devices are connected either via wireless like cab radios and handhelds, or via fixed line or wireline networks like the dispatcher working positions. And what is important, the cab radios attached to these different kinds of networks in this para-flexible way using an onboard gateway. We see this later on. The peers comprise of various access technologies, as already mentioned. We have the 3GPP ones, like 5G new radio, and we have non-3GP ones like Wi-Fi, satellite, and anything else. The dispatchers make use of these connections to talk to the trains, make use of these pairs to communicate with the onboard devices. So having said that, the FRMCS comes already built with a built-in pair flexibility to use various technologies for various areas and to guarantee the connection to the train with the most suitable access technology. And the applications, having said that, like the dispatch application, are then completely pair independent. They can be accessed at any time by various means. And if we look, you know that at dispatcher solutions of today, this is not a concept, this is already existing in real life deployment. So you have a dispatcher core, which provides all the elements and the functions like the session, media handling, media processing, conferencing, as well as applications. Dispatch applications like role management, phone books, train lists, and of course rail applications, functional addressing, rail emergency call enhancements. What is also important, the dispatcher core uses gateways to connect to these various communication networks. We see here GSM-R and parallel usage of public networks. But what is important for the control room, for the dispatcher user, this is completely transparent, and he can make use of all these various connection principles. When we apply now here on the next slide the FRMCS, then this is just adding another communication system from the control room point of view. We can add it to the system view, but from my side there is no common view how this shall be done or how this will be done, at least not concerning the control room. But still we want to use the FRMCS to keep the connection in the rural areas, and I don't think there's a fit-for-all approach, but we have some good options which we can have a short look at. The first option is to integrate the FRMCS, so to connect the dispatcher core to this is really simple. You just implement and deploy another gateway and connect the FRMCS and its different radio access technologies like any other communication network. So this will give you the minimum impact on the deployment of an existing dispatcher core. And of course, these gateways are not hardware boxes anymore. These are just software modules. So if you run already a state-of-the-art dispatcher core rather on bare metal, so dedicated infrastructure or virtualized or cloudified, usually that shall provide enough processing power to add these few software modules for the additional gateways to connect the FRMCS. And the beauty here is that, of course, for the dispatcher working position in the control room on the left, the connection and the usage of this additional network, of these additional radio access technologies is completely transparent. On the side of the mobile devices, the situation is a little bit different. So to guarantee here interoperability and the seamless connection as the train runs them through countries, through various areas, through these various radio access networks, we need this onboard gateway, this TOBA gateway, an onboard box which enables the onboard application to access these various radio technologies. And we have something similar in the dispatcher core, because there we have also the gateways which abstract and translate the proprietary interfaces to a common one for the other core elements. Here it is important, there's still a kind of debate for adding FRMCS as standardization. We favor a so-called UE-based interface, MCX 7 and 8. But here, looking at public safety and Frequentis, we are also after using a server-to-server reference point, which would be MCX3 or MCPTD3, depends on which specification you refer to. So to ease the introduction of FRMCS, that's a rather simple, I would say, option, not fully in line with standardization. So if we look at standardization, there is a different option. Strictly applying the FRMCS functional architecture seen before, we will end up now with this integration of FRMCS and its radio access technologies to the whole system, so to say, to the control room. You see that the dedicated dispatcher core is gone. It's split apart. Of course, the radio application and the dispatcher application remain. They are now so-called application servers, but there is no dedicated session media handling, for example, in dispatcher core anymore. This is all done by the basic services of the FRMCS service stratums. And of course, there are again still gateways or interworking functions to connect legacy networks like, for example, GSM-R. You could now conclude from this diagram, oh my God, everything is split apart and there are so many boxes and I have to deploy this on a lot of server hardware, but that needs not be the case. Again, following concepts of VNFs, CNFs, clouds, Dockers, virtual machines, there are various deployment options. There are various deployment options. What is also important, the interfaces here between this IP multimedia subsystem, IMS, and the applications is a standardized one again, IC, basically based on SIP, a technology which is already in use in state-of-the-art dispatcher systems. Of course, there will be adaptations required, but again, this is not a massive rebuild of your whole system. This is basically a software update. Also to use the other interfaces to the MCX application servers or other interfaces you might need to the IMS, SH or stuff like that. So the implementation of this bearer flexibility in the control systems is already given. And likewise, the connection of the MCX services to control rooms is not a concept or a vision that's already working and also already proven in this bearer flexible way, if I may say. So this is what we did in the recent FRMCS plug tests organized by ETSI, where we also strongly focused on the control room client, of course, but also other FRMCS functionality like user regrouping, IP connectivity, emergency calls. And the vendors outlined here on this slide did a remarkable number of remote tests and test sessions, including demos to the observers. So that's very important to prove that FRMCS is on its way. What we have seen now are two options to enable these various connections, including the FRMCS to the control room for any area, how we can implement and how we can benefit from this bearer flexibility in the rural areas. Never forget our focus, keep the trains moving while connecting to these various communication and radio access technologies. Of course, we can secure the investments, we can secure the interoperability, we can ensure the availability of the control room by using the FRMCS. Still, while there's no one-fits-all option, talk to industry, talk to us, and benefit from the experience of other domains maybe to define the right connection option for any area for you. So I would say let's enable the connection to trains in rural areas from the control room using the FRMCS all together. Thank you.
Thank you, Marcus, for this presentation. I think that I see that you are prepared for any type of system already. And but I like your last slide, which just summarized the key issues which have to be addressed, which is the keep train moving, you say, that's potential. The second is the secure investment. I would like to remind what Dan presented before, that most of the lines are covered with GSM-R today in Europe and worldwide, and I would like to add and worldwide, which is essential as well. And the guarantees interoperability. And when I remember some 10 years before, when we started GSM-R, we had analog system, or 2 or 3 analog systems per country in Europe, and of course in the world even more. And when the train Eurostar was traveling to 2 or 3 countries, he had to carry 4 radios on board. And with GSM-R, we went to only 1 radio, which was enough to ensure the interoperability. And we proved to be interoperable all over Europe and worldwide today, all over countries or continents like Australia, for example, or China as well. So we will have the interesting debate later on, but thank you for this excellent and interesting presentation. I think we move, and I would like that we move to the next speaker because time is running and we have to ensure all the presentations. The next speaker, Markku Utilainen, will mainly address the aspect of the which are the challenges that we are facing for the radio coverage. And Markku, I know that you are well documented on that because we had several discussions on the subject. And so, but you had some questions to the floor, interesting questions.
Yes.
I would like to hand it to you, Jules.
Thank you, Robert. Let's ask the audience the third poll question. Once safety and interoperability requirements have been fulfilled, what are the most important matters for FRMCS rural area communication? So once again, you can select multiple options. Is it cost efficiency? Is it service availability? Or is it high data throughput capacity? So we're talking about over 1 Mbps per train. Was it low latency, less than 50 milliseconds? Or is it network slicing or edge computing? Which of these are the most important matters for FRMCS rural area communications once safety and interoperability requirements have been fulfilled? So once again, the audience members, you have 10-20 seconds to respond while Robert introduces Markku. Thank you.
Thank you, Jules, for that. Markku, I know him since 2002 when he started as working for the Finnish Transport Infrastructure Agency, FTIA. He's led the Finnish GSM-R radio network implementation project, and later on, because it was the decision of the AA to migrate to the existing state security network, he was transferred from GSM-R to this network. He is now preparing the next communication evolution step, how to introduce future rail mobile communication system in Finland. Prior to this railway world, Markku had worked for industry with Nokia and Ericsson in Finland, Europe and Far and Middle East for more than a total of 30 years experience. Markku, we will see the result of the poll now, and I would like to hand over to your presentation when we will consider the result of the polling.
Great, let's have a look at the results. So if the audience members, if you haven't voted, if you can make your decision, we're closing in 2-3 seconds. So final choices, please, and then let's close the poll now, please. So once again, it's under the polls and then closed section. So yeah, a third of the people have said service availability, and about a quarter have said cost efficiency. Robert and Markku, what do you think of that?
Yeah, I'm quite not surprised that service availability is essential in a professional world like railways, as mentioned by Dan as several occasions and Marcus as well. Availability is a key issue. We're not in the public network world when if a call is dropped, you just call again. The number we expect one drop call in 100 hours, which is in the railway environment, which is very huge compared to the public network. So it's very, at least this is the first one. Then we have a split within different opinions on cost efficiency. The high data throughput, and the rest is low latency, which goes to high data throughput, I think. And network splicing, edge computing is just an emerging technology, which probably will be maybe more applicable later on when discussing or talking about the automation with trains. So, Marco, your opinion on that?
Yes, actually, I'm not surprised about this. I think it's the service availability and the cost efficiency. They are I think the most critical part for the moment for the railway safety critical communications.
That's right. That's right. At least we were not surprised with the result, but we see also some views on the high data throughput, which are emerging, and this is of course depending on the evolution of the digitalization of the train operation. Marco, I would like to give you the floor on this your presentation now.
Okay, thank you, Robert. The time is short, and I have named my presentation the FRMCS Radio Network Planning Challenges for the Rural Areas. Actually, we have tried to plan the FRMCS network even before it's fully defined. What does 5G really mean for us as a consumer and for railways? The 5G is already reality in public mobile operators network, but the definition and standardization of the FRMCS is still ongoing. The general goal is to get it as much as possible to be included in the next TSI revision, and more comprehensive package is planned for the 2025 revision as Dan presented earlier. I have gathered here typical characteristics which are often associated with 5G. Ultra reliable low latency communications, which will boost the mobile broadband data rates beyond 10 gigabits per second. And does this picture on this right side present our future when massive MIMO is used in our cars and in trains? But what does 5G really mean for railways? What are the real requirements for the railway interoperability and safety related communication? How to implement all the communication services, not only safety related, in the most cost effective way in rural areas? Actually, this polling result shows that what is the most important matter. And my task has been to study these matters in our organization, and I would like to keep all possible implementation options for the moment open for the moment. Of course, the default alternative is the railway private FRMCS network using railways dedicated frequency bands like GSM-R today. Other alternatives might be purchasing the prioritized services from hardened public mobile networks, possible together with public safety authorities, actually what we are doing today for the voice communication only, or any combination of public and private networks. The situation may vary very much between different countries, but 5G technology enables new and versatile way for different kind of cooperation and hybrid network solution for implementing the FRMCS compliant services in the future. Now we go a little bit theory that Shannon's law and the cost-effective broadband services in rural area. It is an economical challenge to offer mobile now broadband services in rural areas. There is 95% population coverage requirement for some of the frequency bands in Finland, but they cannot provide enough broadband capacity, and this simplified Shannon law explains the reason why. The first option to provide more capacity is to use wider frequency band. Public MNO has got new frequency band for 5G, especially in 2.5 gigahertz area and even higher frequency areas. The drawback is that the frequency bands are not free of charge, and the cell coverage areas of these higher frequencies are significantly smaller, and therefore they are not proper for the rural area service. Second option is to use MIMO techniques, which use the spatial multiplexing scheme to transmit different signals from each transmission antenna so that the data rate is increased without any change in frequency band or transmission power. But the drawback for this is that more transmitter, receiver, and antennas are needed, if you remember the picture. The third one, to use higher signal-to-noise ratio or signal-to-noise plus interference ratio, SYNR, which enables to use 5G higher order modulation and coding schemes. They improve significantly the spectral efficiently bits per hertz per second, as you may see here in the small picture. In GSM-R, this efficiency is about 1 bit per hertz per second, but this solution has also a certain drawback, and I will explain it in the next slide. These slides explain the main challenges to provide a commercial, profitable broadband services in rural area. And about 90% of railway lines in Finland are in rural areas. We did the FRMCS radio network nominal plan and capacity simulation, and now we understand a little bit more about the 5G technology. This picture illustrates how 5G radio interface has been optimized for the downlink direction based on the public mobile network behavior. Even though in the capacity calculation we have used the FRMCS train radio higher output power, which will balance the uplink difference compared to the, I would say, the normal 5G mobile terminals. And the maximum cell data transfer capacity when using 5 megabyte signal without MIMO and in 900 megahertz area can be in downlink direction about 30 megabit per second and in uplink 20 megabits per second. But the capacity drops very quickly when the signal to noise ratio decreases when the user is moving further away from the base station following the last factor of this Shannon law. Uplink direction limits the practical cell radius in this 5G technology. On the downlink direction, the cell radius could be approximately 100% longer, or this uplink limited cell edge point, what is presented here in picture, this red line. There is still about 15% downlink capacity available from this maximum cell capacity. Actually, this here is presented the uplink and downlink Monte Carlo simulation from the same track. They are same track with two pictures. And here you can see that the uplink direction is much weaker. The uplink capacity in many places are between 100 to 500 kilobits, the red color. And while the downlink capacity is almost everywhere on the same track section, more than 10 megabits per second, this magenta color. So the cost-effective broadband communication in rural area, it's a challenge for the railway and for the public MNOs. How to implement fault tolerance, high availability communication services is another challenge. There are those fault correction times and some other challenges there. Today, I don't know how we are going to solve all these challenges. We have budgetary information about the private FRMCS network implementation and the running cost based on our studies, but I would like to keep all bearer flexible or bearer independent FRMCS implementation option open until we have more information available on the FRMCS standardization, CCS TSI revision, and real market offering from the public MNOs. But we have good FRMCS forum in UIC together with the industry and other stakeholders, and I'm sure that to continue to do the work together, we will find solution to these challenges by using 5G's enhanced feature as functions in the most cost-effective way. Thank you.
Mark, for this presentation. I think it's an interesting view on the technical, the coverage aspect.
I think Robert's out. I think you're back, but
Of the availability of the network for FRMCS, and I think that you partly answered to that, but also another point in the poll was related to the cost, and was a driver for efficient rail operation, especially in what, as you mentioned before, 90% of the network, which is rural in rural areas. So I think that we could launch the poll to know how important the cost is, because it's related to the cost. So Jules, could you just so that
perfect. Thank you, Robert. So the fourth poll today, if the audience members can once again respond, please. What is the cost split between the station infrastructure, so including things like buildings, energy, fixed line communications, and power, etc., and the radio equipment? What is the kind of cost split? What do you think is the cost split? Is it infrastructure being less than 25% of the total cost, or is it between 25 and 65%, or more than 65% of the total cost? So if you could respond, please. This will be a quick poll. Robert, would you like to introduce the other speakers while the audience votes?
With pleasure. Now we have two more excellent speakers which will join us. They are in the rail operation day-to-day, so very interesting for us. You have Eric Giraud-Desjuseurs, who is the head of the GSM-R network at SNCF, and Carlos Rincon-Abel, who is the senior telecommunication manager in ADIF, who is the infrastructure manager in Spain. And the first one, the SNCF, is in France, of course. Eric first, let's start with Eric. So Eric began his career in 1988 in the industrial SPI group, dealing with refurbishment of power plants. He moved to the railway business in 1998 for Siemens, working as a project manager for automatic metros and tramways. In particular, for some, as an example, he was in charge working on the Singapore Circle Line, the extension of the Paris Metro Line 14, or the Algiers tramway. In 2007, he joined the SNCF Group as project director of the Charles de Gaulle, which is the airport, big airport in north of Paris, Express, which is a express line, and the RER-B North modernization. Since November 2016, he's the head of the GSM-R network at SNCF Réseau in France, and looking at the evolution toward FRMCS. As far as Carlos Rincon Abel, he is the telecommunication manager at ADIF during more than 15 years, and now he's in charge of telecom engineering in project and network deployment, which includes, of course, the GSM-R, the FRMCS, the fiber optics, WDM, and cybersecurity, and everything which is dealing with telecom in railway environment in Spain. For high-speed, commuter, mainline, and freight corridor, who has a very big experience of different modes of transport in Spain, telecommunication in Spain. He also takes care of the customer public operator contract within the telecom ADIF internal operator. The dealing with the portfolio, inventory, pricing, tarification, workflow management, and new services in an incident. So you see that we, around the table now, we have a lot of talented experts dealing with that. And maybe we can start with the poll which was launched.
Yes.
Jules,
yeah.
You have the
so I think most of the audience has responded. So let's close the poll now. Thank you. So you can have a look. Now you know where to have a look. We have a close tie. I think B and C that sort of tied, Robert.
Yeah. At least I'm happy to see that there was. I'm just surprised to see that 50% think that the infrastructure cost is less than 20% of the total cost. I think that Eric and Carlos, you might have some views on that, and but I'm happy to see that also 42% think that it's more than 65%. And Eric, I think we have the answer. You know, for a big network like the one in France, you probably have numbers that you can give now, unveil today, and to the audience.
Yes, well, thank you, Robert. It's sure that, if you're talking about dedicated infrastructure like GSM-R, it's the good answer is C. It's more than 65% of the total cost, because on the other way you have the cab radios. But for the thing, we all pretty well know that GSM-R infrastructure, the implementing of the GSM-R infrastructure was very, very expensive, and that's why we must now manage the asset properly. And see what we can do with this network, because it's for instance in France it has been implemented not all in the totally, but on our main lines, on our performance lines. And so of course if you use some MNO's network, then the cost is less, but it's not the same service, as we'll see.
Thank you, Eric, for this interesting information which is delivered. And we, I think, Carlos, do you have any comment on that as well? Carlos, you are muted.
Sorry. Yes, I could take the point to comment. It was some like surprising for me the general confidence in the MNOs networks, and I don't think MNOs will deploy their 5G networks to cover lines through rural areas, making it possible for railways just to contract with them. For the time being, our experience is that there is no good public coverage in rural areas, even at high-speed lines, where we have deployed sites, towers, energy, everything for them just to deploy their equipment and serve the coverage. And from now in advance, MNOs will invest even less than they did in the past. So if we as Railways wanted an MNO to cover rural areas with 5G ready for mission critical services, it will be much more expensive than deploying ourselves a neutral 5G network. So I agree, the infrastructure is the most costly part, but I don't think the MNOs would be an option to make it cheaper.
Thank you, Carlos. Eric, I think that we could, to complete the poll, may I ask Gil provide to get more information on what we mean by rural. I think that we have a question, questionnaire which is raised that I would like you to, in between, I would like to ask a question to other members.
Yes, so if we can launch the next poll, please. So this is a poll question proposed by Eric. Which of the following would best describe the way rail sees rural areas today? So if you can choose one of these four, please. An area where the population density is very low, or is it a territory to be irrigated by an efficient service of regional lines? Or do railways see rural areas as a corridor where it's possible to
I would like to now, in between, just a quick question to Eric. Are you sharing the viewpoint from Carlos regarding the use of MNOs?
I would say I'm sharing some of the views. That is to say, I think we must define what's a rural area, and especially I think we must define what kind of line and what kind of services we need in these areas. Well, I think we will need.
Yes, Eric.
Two. Yes.
Yeah. So maybe we,
yes,
if you allow me, maybe Dan, do you have any feedback on of what you have seen regarding the different polls which are launched regarding the different system? I have questions from the floor regarding the use of frequencies.
I haven't seen. I don't remember seeing that particular poll yet. I think that there are a number of yes. I mean it was this one. I went actually for 3 technologies there. I think first of all there will be a development in the future, as you said, on satellite. I heard about some tests in UK with the new Mr. Tesla satellites, which are a bit lower orbit and deliver a very high throughput. You need a specific antenna. Then, of course, there will be the MNOs 5G, and then we see also what MNOs can offer. The problem that you have is that if you go with a 4G another technology, you will have this problem of do you use the mission critical mechanism or not? But in a certain country, more or less on this continent, you can do a system which is completely electronic. Normally on a single line, you do run on site. Basically, controller A is calling controller B. I'm letting the train go into you, and there's a way to do it electronical. So there are systems to be imagined in rural lines with partial coverage and all these kind of things. And also satellite has to be proven how reliable is it, and what do you do if it's not there? So I think that when it comes to rural line, there are more. It is more than one technology that should be considered, and I'm pretty sure that from SNCF or from ADIF, all these things are probably considered. At least when I was in my role in NetOrail, we were looking original lines to more than 4 or 5G.
I would like to add here, I mean, I'm fully with you, Carlos, that building or forcing or asking an MNO to extend his network to cover all rural lines is a challenge. I think it's about the combination of the various technologies and networks, and also about which sharing option we choose, whether it's just RAN sharing or core sharing or slicing in the future. I think really that we have to be careful to rule out an option per default. And maybe the public operators will also change their mind if we see what they intend to do in Finland, in Poland, or in other countries, or where they're considering public networks as fallback, like in Australia already.
I think, Marcus, so I have two things to answer. Am I allowed to answer, Robert?
Yeah, go ahead.
I think I have two things to say. The first one is, that's the beauty of this group called ERIC. We should, I think in every country there is something done in particular. I think there's no particular railway that is doing waiting for others or doing what. Everybody has its own idea because something particular. What is smart is to share, because at the end, if it has the right quality, it has the right KPIs, it's good. When it comes to slicing, I want to make clear something. So we have to be careful with the slicing from a certain perspective. Theoretically, it's perfect. Now, for who is a bit gray hair like me, remember the MCBTS. When in GSM-R we got the multi-carrier base stations, we were so happy. And then when we tested it, we remember that because of the large frequency technology, the shape of the frequency was not good enough for us. And this is why I insisted in the SDA that what I showed the lines I showed in my slide were the lines from the SDA. Now I'm coming after 6 years of UK, where the policy is the document on which you run the railway for the next 5 to 6 years. So I treated this SDA from the Commission very seriously. And I know that you were there to support Eric. We could not have written without you, and also Marco, and I think that's a good document. So on slicing, I think we need on a good lab or a good test line to start to test a bit and to understand what does it really mean, because it's not even sure, it's not completely implemented. It's going to release 18. So we have to be very careful on this one. I was not negative in what you said in any way. I'm just saying we have to be careful. But on the other hand, I think, as I said, that I'm happy with the testing done in Finland. I'm happy with other concepts in France, in UK, as you said, in Poland, because then we have a diversity and we can. That's the beauty of ERIC. We can share between us. Because at the end of the day, if the model is successful, then everything is right. No.
Thank you, Dan.
And we have to be flexible.
Thank you, Dan. Marcus, I have a question for you. And together, I think Marco could also think about that. When we speak about the usage of MNO, we speak about the complete. It's not only the radio access; they're the complete system. So, what about the challenges we can face regarding the control room when the system is operated by telecom is operated by the MNO?
Yeah, a main challenge, of course, which we also experience, if I may say so, for example, in Finland, is security, because basically you are connecting to a public network, which is per default more open than a dedicated network specific for railways. So you have to be careful, and I've also seen a question around that in the Q&A list. You have to be careful how to secure your control room. You might need a DMZ, for sure. You might need concepts like SPCs, or even further security measures on application level, like we have then in the future end-to-end encryption of MCX or MCPTD. And you always have to think about in the control room or the whole communication system about the trade-off between security, safety, and so to say recording or post-incident analysis. If you make a system super secure, it might become unsafe and you will not be able to record anything. There we see the biggest challenges. If I may add, also not only specific to railways, but that's a real interdomain problem for the public safety friends as well, who have to solve this, for example, with us in Met Police, where they're also using public network for MC, PTT communication inside towards the control room.
We have several questions which are raised from the floor. One is regarding but before that, I would like that not only when thinking for coverage, we also, not only the radio access technology, which is on Earth, but we can think about satellite system. And I would like that Jules, could you launch the poll regarding the questionnaire which was sent? Thank you. In between, as you have seen, there is a question regarding the overlap from GSM-R to FRMCS, how long it will take, and I think that Eric could give an answer.
So Robert, on the satellite communication questions?
No. The overlap from GSM-R to FRMCS. How long? What do we have? Will we have the two systems in place, and for how long?
Yeah. Oh, I think it will be the same between allergic radio and GSM.
Sorry.
More than GSM-R missions in 22, and then we will have to make some pilots together in order to test all this. We will have to have the equipment ready, and so I'm pretty sure that the first lines could be put into service in 2027, 2028, and then the massive migration could start in 2030, between 2030 and 20. Between 2030.
So more than 2
dates. We must think about it.
Yeah, but it's a range of 10 to 15 years, if I understand correctly what you say.
I didn't get you because the link wasn't very good.
Are you thinking to 10 to 15 years of overlapping?
Overlapping, yes, but that doesn't mean necessarily that the two systems on every line will coexist together. That just means that the overlapping of the two programs will be this, yes.
Then the question probably, which is important, is it when we talk to low density lines, do you think that low density line you will hear the GSM-R for longer than for high-speed lines, for example?
Well, I think, a few people said it before, you see, for instance, in France, we don't have the same systems in low density, low traffic lines, in low areas, low density areas, and in dense areas. We use, as I said, two kinds of quality of radios. One where you just have the railway emergency call, the REC. You have some phones and mainly for crossing, and you have also, of course, a way of communication with the driver. And on the second way, you have to have another quality of radio, and this is GSM-R, this is FRMCS. if you start to talk about interoperability, if you can start to talk about the communication to control the train, and that is to say TCS, ATO, ATS, and there we must be very prudent on what we're saying, because for this system, the matter is the quality of the coverage, which is more than 99% and sometimes 99.99. And the second point is the real-time monitoring of the system. You have real-time monitoring of the trains, so you need to have real-time monitoring of the telecom controlling the trains. And this is very important. And that's why if you have a failure of your communication system, the train stops. So you must be aware of that. Another thing is in rural areas, you can have few kinds of lines. That's why, on the pool question, I think all the answers were good. It depends on what you call an area. I prefer call a line and a typology of line in this area. You can have high-speed trains linking two big cities in a rural area. It's better because if there's nobody, it doesn't make so much noise, and etc. And that's why for these types of links, when you have, for instance, a high-speed train at 300 kilometers per hour and a spacing of 3 or 4 minutes between those two trains, you must be completely sure of your communication system. You must be completely sure of the way you're monitoring this. But you see, that doesn't mean that you need it everywhere. I just say we must analyze together all the markets and see what's the secondary lines in the rural area, what's main line, and what's, I would say, mass transit and high-speed lines. If you have, for instance, the three categories, then you can put your system. And I would say, using the MNO, then it's more an economic problem or a regulation problem than a technical problem. I'm pretty sure that they would be able to do lots of it, but it depends at what cost, and it depends if it's construction or operation and maintenance.
If you look at now at the answer to the poll regarding the satellite.
Yes, so I'm sorry about my communication connection issue. I hope you can hear me. The last poll on satellite communications, I think most people have responded, and we've closed the poll just now. And you can see, so we asked about what you thought about satellite communication, whether it's an option for rural area railways. And the last option, no, as GSM-R is already there, FRMCS will be the best option, as opposed to, yes, satellite could be an option. So the last answer, C, had the majority of the responses there, Robert.
Yep, thank you very much. And Carlos, you at least.
And sorry, so we're getting close to the end of the session, but there are a lot of questions being asked from the audience. And if the other speakers are okay, I propose that we extend by about 10 minutes. If that's okay. So we can continue until 2:40, something like that.
2:40, okay for me.
Yeah,
great. Thank you.
I think you were expecting.
It's okay.
If I understand correctly.
If we can, sorry. Yeah.
Actually, the questions are more answered exactly as Eric said. More answers are correct, because if you already have GSM-R, then you're going to use GSM-R as long as you can, and obviously because as a railway you try to do cost efficient. Everything is right. I'm not sure. It depends on the technology if B will be valid. I never say no, because who would have thought 5 years ago that 1 year ago you have artificial intelligence on your smartphone? who would have considered that 4 years ago? So knowing what's happening in the satellite area, how can we say no? It depends on technology. Technology will evolve. And I think I'm very curious on the test that will be done in UK on the result of it. I'm not sure how reliable the Mr. Musk satellites are, but it's a very interesting thing. So satellite could be in the future an interoperable thing, but let's wait for a bit of improved technology. You can never say never, but for me, A and C are definitely a go. So you have more than one answer there.
Okay,
Exactly.
thank you, Dan, for that. If I pick some of the questions which are raised by the audience, I see a question from Jean-Marc Charroux. He's asking if the MNO could accept that the railway could have the priority in the allocation of frequency band to allow the traffic, essential traffic that they have. And Markku, would you like to answer to that question?
Yes, actually, in Finland, the Public Safety Authority concept is based on that there will be a one selected public MNO, which radio network is hardened, and they will get prioritized and preempted services up to a certain capacity. And that was they don't have planned to use any own frequencies when it's time to leave the existing TETRA technology. But the legislation has been changed that it's possible to offer to a dedicated user group these services within the EU. So we will have a real case that we tried to do this. But I don't know today how successful we are. But therefore, I would like to keep all the options open, because GSM, the 5G, we are just in the beginning of it. And the major rollout will be, I would say, closer to 2030. And as Dan Murdoch said, in 5 years, telecommunication, things might change very much. So therefore, I'm promoting that let's keep the opportunities open. And of course, I understand even this polls the priorities, what are the most important things that for the railway, that was quite clear.
Yeah, I think Jean-Marc was meaning that any MNO, and I'm happy to hear it from your side, that there is typically it's a shared specific network which is deployed in Finland.
Yeah, it's the radio access network is shared, but then the public safety authorities, they have the core network on all their applications, and things are in their 100% own control.
Which is different from just using the service from MNO.
Yeah, that slicing to get slicing, because it's only, I would say, the radio access capacity. And then it's also they need to densify the network in the rural area where the population, where the coverage is not good enough.
Yeah.
But this is ongoing project, and we are following it, and we will see in 1 or 2 years that how successful they are.
Robert, let me please. I'm seeing a question from Michael Bond, which is I think interesting. And let me talk from a railway administrator point of view, because we have to take choices. Everything is open, technology evolves, but we have to take decisions. And I think we have to say clearly, we should start now deploying a neutral 5G network ourselves as a railway administrator at the station and along rail tracks, radiating MNO's bands and giving them out the traffic in their course. MOCN would be the best approach, but we can manage this afterwards because of 4 main reasons. First, we can take advantage of the funds Europe is offering for 5G deployment some of them particularly dedicated for railway corridors. Second, we can deploy in a very cost-effective way, as we can reuse existing sites of present railway radios, analog, PMR, GSM-R. We can use sites, towers, optic fiber, and so on. We already have contracts for the maintenance of all these kind of assets. Third, in this way, we guarantee in the short term, let's say next 5 years, good 5G coverage for passengers and railway operators and administrators, which can boost the case uses the railway sector need and 5G promises. And finally, having deployed a 5G infrastructure, we will find it ready for FRMCS when migration from GSM-R starts. In 5 years, as you are telling, we are planning to start migration, and it's better migrating from this point than from scratch. We will be able to start relating by this infrastructure our own frequencies for our mission critical services.
Yeah.
Thank you.
And yeah, I would like to just add, thank you very much for this answer. And as you know, if the tower is deployed in close to the railway network, and which is exactly where you have the handover, that it's terrible for the operation of the railway system. So we should avoid. So coordination is necessary and essential. The coordination with all MNOs is quite not easy, based on experience. And I think that Eric can have a big experience in that, as most of the railway operators. Yeah, thank you for this this answer. So I think we're answering to that sharing of towers, etc., if possible, and I think it's in application today. If I'm not wrong, Eric, you can just confirm that this is the case in France. Sharing of towers with the public operators, mobile public operators.
Yeah, indeed, we are sharing our towers with the public operators, and we are studying a way to improve this for FRMCS, because we know that we will have to add some other towers for the future system, especially using 1900 megahertz. And so it's true that we will have to have a partnership with the MNOs.
Okay, thank you very much. I think the frequency aspect were answered by Dan already regarding the possibility to use 400 megahertz or 700 megahertz, for example. Marco indicated. I know that in Marco can confirm that it's in the safety services are in 900 megahertz. They are using the GSM-R band. But apart from that, multiplying the frequency mean also multiplying antennas. And I'm afraid that if we just consider the frequency possibilities of antennas on the roof of the trains, that's quasi impossible, or except to have just local only with antennas on the roof, which is just carrying one local plus another wagon just with antennas on the top. So that's not feasible for now. Jules, I think we are reaching the end of the webinar. I saw that for me it was extremely interesting, and the answer was so challenging that most of the speakers had to answer to, and I'm sure that we still have 100 answers to the question from the floor. There is a possibility which you probably will express to continue the discussion and get answers to the question from the floor. And could you just confirm that and indicate to the people how they will get possibly answers to that question?
Yes, so thank you, Robert, and thank you to all the speakers. We do have a LinkedIn event group, which if you search for International Railway Summit, you will see that, and your audience members, and if the speakers, if you're happy to be part of the chat there. There's a specific page for this particular webinar. So we'll send you the link to that page and via email, and you're welcome to ask questions there, and hopefully some of the speakers will be available to answer the questions on that page, so we can continue the debate there. And thank you for all the questions. That was a very, I think, active question Q&A section today. So thank you to the audience for asking those questions. And I clearly, I can see that 90 minutes wasn't enough to respond all these questions. Thank you to all the speakers for the very informative, insightful debate. I think we've learned quite a lot of things. Very topical issue, and thank you to Frequentis for giving us the opportunity to debate this. I'm sure this is an ongoing topic that will be debated more and more in the future as well. So hopefully there will be another opportunity in the future to get together once again to discuss this topic. A very quick information about the next webinar. So this is the last webinar before the summer holiday season. This is next week, 7th of July. We're talking about restoring passenger confidence in rail, the power of demand management. So we'll be talking about passenger flow in stations and on the trains. We'll be talking about how we can encourage passengers to come back to rail. This is a very important topic in this pandemic, but also beyond, how we can convince the passengers to come back to rail, and how can rail operators and infrastructure owners provide the confidence that's needed. And this is clearly one of the biggest issues the railway operators have at the moment. So we'll be welcoming contributions from two public transport operators, Madrid Metro and Transport for London, and once again from UIC, Dan's colleague Mark Gigon, head of passenger division and coordinator of COVID-19 task force, will be providing presentation together with Viovo, the passenger flow experts, and the debate will be moderated by a partner at McKinsey and Company. So this will be next week on the 7th of July, so you'll be able to, the registration is open now on our website, so do visit our website for that. So thank you again to all the speakers today, Dan Mandok, Markus Mislevic, Markku Voutilainen, Eric Giraud de Juseau, and Carlos Rincon Abel, and of course thank you to our moderator Robert Sarfati. I hope you can join us again at the next webinar next week, and until then, thank you very much, and goodbye.
Bye.